All right, everyone. So we're going to continue on with question one. We're going to actually go through how to solve it. I'm going to focus on solving the algebra today. I'll do another video after this where we can solve it graphically. So looking here at our work that I did in the first video, we don't need all of it. If we're not doing this graphically, I don't need the graphs. So cool thing is I can turn those on and off. Kind of fun, right? So let's go ahead and start trying to solve this. So if we're going to do this, come on you, if we're going to do this graphically, sorry, if we're going to do this algebraically, the first thing I got to do, I got to solve for these velocities. I didn't do that last video. But I'm going to go ahead and resolve for these two, actually do the trigonometry here. Now, let's see, do I have it? You can show the calculator. Yep, here's my calculator. So if I'm going to go ahead and do the calculator, we know that the horizontal is 1.5 times the cosine of 20. So I get 1. I'm going to round that to 1.41, if you're okay with that. So this is 1.4, oops. Sorry, I'm going to 1.41 meters per second. And then the horizontal part, sorry, the vertical part, 1.5 times, oops, 20, oops, sorry, 20 times 0.513. So I'll go ahead and draw that off the side here. 0.513 meters per second. So a little ugly, but that'll fit. All right, so let's go ahead and solve our problem here. So I'll go ahead and switch to another color here. We know that generally the way these problems work is we have some goal, right? In this goal, it's that x value. So we need to find a way to get there. But we don't have enough information here on the left-hand side to solve for it because we don't have the time. So what we're going to usually do is use the information from one side to solve for the time, and then use that time to solve for the other side. So let's go ahead and figure out how that works. Here, we need to solve for time. We have accelerated motion, and we know positions more than we know velocities. So that's probably probably the best option we have is this equation, that the final position will be equal to 1/2 the acceleration times the time squared plus the initial velocity, vertical, times the time, plus the initial vertical position. So this equation, vertical acceleration, this equation, this is our normal accelerated motion model. This should work out just fine. This will be some parabola. Yeah, we could go ahead and solve for this. So I'm going to go ahead and plug in all the numbers and see where it goes from there. So we know that the final position, it's going to hit the floor. So that's at 0 meters. This will be 1/2 the acceleration. The acceleration is -10 meters per second squared times the time squared. Now I don't know what the time is yet, but we'll get there. I'm going to try to make my t's curly so that we can tell the difference between those and their plus signs. Plus the initial velocity, which we know is 0.513 meters per second times the time plus, oh, did I not turn off the calculator? I did not turn off the calculator, sorry about that. It's annoying. Plus the initial position, which we know was 1.3 meters, and that does not look like an M, that looks like an N. This is solvable. That said, it's a quadratic. So how do you solve a quadratic? There's a few ways. And if you want to, I'm okay with you using the quadratic formula. I like Lowe's method, but no one knows Lowe's method. That's fine. And I'll also let you graph it. So here, first let's do the quadratic formula in case you don't remember how. And then after that, I'll show you how to graph it and actually get the answer from that. So we know that to solve some formula where 0 is equal to ax squared plus b x plus c, that x will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Hoping you've seen that before. If you haven't, it's been a bit, right? So I'm just going to start plugging this stuff in here. So negative b will be negative 0.513 meters per second plus or minus the square root of b squared. So b squared, go back into my calculator. I get 0.263 meters squared per second squared minus 4 AC. Now, A is 1/2 of negative 10, so it's negative 5 meters per second squared. And then C is this 1.3 meters. And then all of this is over 2 times A. Well, 2 times 1/2 times negative 10 is just negative 10 meters per second squared. Ultimately, we're interested in an answer that has a positive value, so we're probably just going to deal with the plus. Now, you could go through and solve this like here. In fact, you should be able to. I mean, you're juniors and seniors in high school. This is pretty standard stuff. But I'm going to be honest. I'd rather have you cheat. And by cheat, I mean, let's let Desmos do the work for us. So let me show you how to do this in Desmos. Now, you could, if you wanted to do this a few different ways, you could do this in a graphing calculator. You could do this all over the place. But what I'm going to do is I'm just going to type it into Desmos and see what Desmos says the answer is. So on Desmos, we have to turn, we have to make sure our position is our vertical axis, so that'll be y. So y is equal to 1/2 times negative 10 x squared. Now I'm changing this to an x, so I don't have to think about t's and x's. I guess I could probably keep it a t. Plus, and this was 0.513 times x. And we'll just make it less confusing and make them both t's. Plus 1.3. And guess, look, it says that it should hit the ground twice. Once before we started, right here, but that's not useful because that's not real. This would be like somehow if we went back in time, we could imagine that someone could have thrown the ball up and landed in the same spot. We care about this one, which says it should hit at 0.564. Now, beautiful thing is, I trust that. It's just a calculator. I look at my equation, it matches. So yeah, I'm stealing that. Now, I actually have gone through and evaluated this quadratic here, and you do get 0.564, just in case you are wondering. Desmos does get us the right answer. I'm not your algebra teacher, so I'm totally fine with you using Desmos. I'll let Shortvager and Lawler fight you over that one, okay? So when we throw this into Desmos, I get t equals 0.564 seconds. Beautiful, wonderful. So let's go back and look at our value here. So I'm going to go ahead and plug in 0.564 seconds. Now that we know how long it's running, well, we also know how far it goes in every one of those seconds. We know that every single second it's going to travel 1.41 meters per second, or 1.41 meters. So horizontally, we just know that the final position will be equal to its initial velocity, this 1.41 meters per second, times the 0.564 seconds that it's running. That should tell me where it lands. So if I go back, turn on my calculator so you can see it again, go back and look at my calculator, actually here, let's drop this, 1.41, 0.564. I end up getting that it's going to land here at 0.794 meters. So 0.79 meters. That's it. So yeah, when this ball falls off, it lands right about there. It's traveled 0.794 meters before it hits. And that seems pretty reasonable. So yeah, I'm sticking with that. Didn't tell me it went like 100 yards or anything. That'd be a problem. Okay, so as a reminder, I would expect you to be able to make these calculations. I'd expect you to be able to solve this problem. But remember, it's not just about finding some final answer. The idea is that you're able to fully move throughout this problem. You should be able to tell me the velocities when it hits. You should be able to, I don't know, I probably won't push the trig here, but you could even be asked to calculate the angle at which it strikes the ground. Um, Maybe we'll do an example like that in the future. But this, I should be able to ask you a ton of questions about this sort of problem. All right, everyone. I want to do one more video where I'm going to actually solve this graphically. Again, I like it. I think it's nice. I think it's prettier than the algebra. And honestly, I think it's easier. I think it's actually a lot easier. So as always, let me know if you have any questions. Drop it in the Discord, email me, go to Classroom. All right, everyone. Have a nice day.